Ever wonder how AI can understand a video the way humans do? Like not just see the images, but grasp the story, the sounds, and even the subtle clues hidden in the audio. That's the magic of multimodal reasoning, and it's one of the hottest areas in AI right now. Let's break it down. Imagine you're watching a video of a chef cooking. Humans don't just see ingredients and movements. We infer the recipe, the mood of the chef, and even predict what's coming next. But for AI, this is like trying to solve a puzzle with half the pieces missing. Current systems struggle to connect what they see, hear, and read in real time. They're great at spotting a cat in a photo or transcribing speech, but when it comes to reasoning through a complex video, they hit a wall. Why? Most AI models use a technique called reinforcement learning, RL, which is like training a dog with treats. The model tries actions, gets rewards, and learns from feedback. But here's the problem. Traditional RL methods like GRPO are on policy. They discard old data after each training round. Think of it as a student throwing away their notes after every test. That's super inefficient, especially for videos, which require massive amounts of labeled data. Plus, GRPO has two big flaws. One, the vanishing advantage problem. When all the answers in a group are the same, like all correct or all wrong, the system loses its ability to learn. It's like a teacher giving the same grade to every student, no matter who studied harder. Two, uniform credit assignment. GRPO treats every step of reasoning equally. But in reality, some steps matter more, like figuring out who's speaking in a video versus summarizing the scene. Enter a V ATAR, a new framework that's rewriting the rules. Let's dive into how it works. First, a V ATAR uses an off-policy architecture, which means it doesn't throw away old data. Instead, it stores experiences in a stratified replay buffer. Think of it as a smart study group that revisits tough problems. This buffer prioritizes samples where the model previously failed, making learning more efficient. This alone boosts performance by over 35% in sample efficiency. But here's the real kicker. A V ATAR introduces Temporal Advantage Shaping, TAS. This is like giving extra credit to the most critical parts of a task. For example, in a video, early steps, like spotting the speaker, and late steps, like combining audio and visuals, get more attention. TAS ensures that the model allocates its computational resources where they matter most, avoiding the pitfalls of uniform credit assignment. To illustrate, imagine a video of a dog barking. Traditional systems might treat every frame equally, but a V ATAR would emphasize the moment the dog's mouth opens, visual cue, and the sound of the bark, audio cue, then link them to the context of the scene. This hierarchical attention mechanism allows the model to build a coherent understanding, much like how humans process information in layers. The implications are huge. A V ATAR's approach isn't just about efficiency, it's about precision. By decoupling temporal dependencies and focusing on high-impact decisions, it bridges the gap between raw data and meaningful insight. This could revolutionize applications from video captioning to autonomous systems that need to interpret complex, real-world environments. So what's next? Researchers are already exploring ways to integrate a V ATAR with other modalities, like text and sensor data, to create even more robust models. The future of AI isn't just about seeing or hearing. It's about understanding in a way that mirrors human cognition. And that's a story worth watching,